All right, today we're going to be talking about what's called compound inequalities. Now we're going to solve compound inequalities starting with the word and graph their solution sets. This is often called the intersection. Now when you're doing an and problem, there is only one section that's going to get filled in, and it's the section that they overlap. And I'll explain that as we go through some of these examples. But typically, compound inequalities makes three sections on a number line, and we're only going to fill in one of those sections. All right. And our second objective is that we're going to do compound inequalities with the word or. So we have some with and some with or. Now, or is considered a union. It's kind of a joining. The and is the intersection where they overlap. The or is the union. And now when we do the union, there's going to be two sections that get filled in. And any section with a line on it is going to be getting filled in. That's why it's a union. Everything's coming together. It's not just where they overlap, it's we're going to take everything. And you kind of have that in a union. All right, so let's graph an intersection. Now, this is an and problem. How do I know it? Because they have the word and here. Now, the and is, we're going to go ahead and deal with an intersection here. Now, a compound inequality is two different inequalities combined by either an and or an or. This one, of course, is going to be and we're going to do a bunch of ands to start with, and then we'll do the ors and show you how that's different. So we're going to go ahead, and our answer is actually going to be a number line that we're going to have at the bottom here. But we're going to graph both of these first. And I'll show you how we do this in just a moment here. So I have the graph y is greater than 5, so that's a closed circle on 5 and going to the right. Now, we have also y is less than 12. That's an open circle on 12 going to the left. So here's our two different graphs. Now, to find an intersection, notice what happens here. This point here, this 5 from the first one, kind of makes a dotted line. And this 12 makes a dotted line. So I've got a section here that's less than 5. That's section 1. Section in the middle here is 2. And a section that's between 5 and 12. And the section over here that's greater than 12 is section 3. So there are 3 sections. Now, remember what I said, an and is only going to have one section filled in for our answer, and it's the section where they overlap. Here, there's nothing on top, there's only on the bottom. Here, both of them are, and then over here, we only have one. So we are only going to fill in this middle section where they both overlap. And so we fill in from 5 to 12. Now, notice the 5 and the 12 have the same symbols as what they do on these graphs. The 5 is closed and the 12 is open. So I'm going to have the 5 closed and the 12 is open. Now, this is a really easy one to go ahead and do because you don't have to solve anything and you can just graph it. But you should be able to go ahead and do them even if there's ones to solve. We just solve each of them separately and then put the graphs together. And that's what we're going to be doing today. All right, so let's look at another one here. Y is greater than 6, so I have a greater than 6. And I have a less than or equal to 10, so a closed on 10 going this direction. Now again, I have sections 1, which is over here, section 2 in the middle, and section 3 over here. I am looking for the section where they overlap, where they are in common. And that section is section 2, so I bring down the appropriate endpoint. So this is an open circle, and this one's a closed. And I fill in the points where in the middle where they overlap. Now, ands tend to be the middle, but they don't have to be. They can be section 1 or they can be section 3. But more often than not, you'll see them in section 2. All right, this one is an and problem also. This is the one tricky one. This is an and problem even though they don't say it. It's a kind of a shortcut way to go ahead and write an and. So you'll see this occasionally. You just need to know that this is an and. The ors will always say or. So how do I make two equations out of this? The easy way would just be 7 is less than z and 2 is less than 11, but we can't. This middle part, this z plus 2, is part of both equations. So notice what happens. It's 7 is less than z plus 2, and the z plus 2 is less than or equal to 11. Notice that middle part gets used twice. It's kind of a shorthand and a little bit of I don't want to say a lazy way of writing it, but a simpler way of writing it, so you don't have to write z plus 2 twice. So you will see this occasionally because it's easier to write, but just understand that z plus 2 goes with both. Now we can go ahead and move this and solve these now individually. So I'm going to minus 2 from this side, and I'm going to minus 2 from over here. The nice thing is they do tend to be very similar on how to solve them. So if I subtract 2, I subtract 2 from both sides, and I get 5 is less than z, and z is less than or equal to 9. And we can write it that way, leaving it this way. 5 is less than z is less than or equal to 9. But in order to graph it, we will want to go ahead and switch that around. So instead of 5 is less than z, we're going to want to write z is greater than 5. Flip that around. So greater than is an open circle going to the right. And the 9 is less than, so it's a dot here going this direction. And then we have our different points here. So we have section 1, section 2, and section 3. Well, where do they overlap? That's in section 2. So the answer is only that section 2 and the endpoints that follow. All right, let's try an OR. Again, how do I know it's an OR? It says OR. Now notice this one here is not as easy as our first AND problem. We're going to have to actually solve each of these separately. Now the nice thing with the other AND problem was that we could go ahead and solve them pretty much the same. We subtracted 2 from both of them. The OR problems are not going to be that way. They are very different, so we have to solve them differently. So let's just start with one of them. The 4k minus 7 is less than or equal to 25. So how do we solve that? We add 7 here. Ignore this for right now. We'll come back to this. I'll walk you through these in just a minute. So 4k minus 7, so we go plus 7. So 4k is less than or equal to 32. Divided by 4. And that's a positive 4, so I'm not switching my sign. So it's k is less than or equal to 8. So that's one of them. And then I got to do the other one. This is a positive 12. Remember, the negative goes with a 9, so it's a positive 12, so I have to do minus 12 to both sides so that those will cancel. And you get negative 9k is greater than or equal to 18. Then we do our divide, and we divide by negative 9. And when we divide by that negative, notice we switch the sign. This is the only point that we look to see if we switch the sign, and we do here. And so then k ends up being less than or equal to negative 2. All right, so now let's graph these. K is less than or equal to 8 is a closed here going this way. And less than or equal to negative 2 is closed here going this way. Now, we're going to go ahead and have our different groups here, 1, 2, and 3. Now remember, an OR will always have 2 sections filled in. This section over here has no answers, so we're not filling that in. This one here does, so we get that filled in, and this one has both, so that gets filled in. Now notice what happens here. There's really not an endpoint here, so I don't really need that dot there. Actually, if you put that dot there, I'm probably going to mark it wrong. The only endpoint is this one here because this just keeps going through. So the only endpoint we need is this one here, and this is my answer here. So the only answer is really just k is less than 8. And you'll get that a lot with an OR, okay? Most of the ORs do tend to be the outsides, just like the ANDs tend to be the middle, but it doesn't always have to be that way. If you look at this graph, it isn't. It's section 1 and section 2 that are getting filled in. The only thing that doesn't get filled in with an OR is anything that doesn't have any answers. So this one doesn't have the answers, so we don't fill that one in. All the other ones work, so that's fine. So we can try another one. Again, this is an OR. So negative 2x plus 5 is less than 15. Go ahead and solve this. Subtract 5. Negative 2x is less than 10. Divide by negative 2. And we're dividing by a negative, so we flip the sign, so x is greater than negative 5. So I graph that, open circle, going to the right. And then I go over here and solve this other one. Subtract 15. 5x is greater than 5. Divide by 5. That's positive 5, so I'm not switching my sign, so x is greater than 1. So there's an open circle on 1. So again, I have 3 sections. Section 1 over here has no answers, so I don't fill it in. This one has an answer, so I fill it in, and this one has both, so I fill that one in also. So there was 3 sections. This one doesn't get filled in, the other 2 do. And then we have the ability to go ahead and do these. We should be able to go ahead and take our graph and write our equation appropriately. Now notice there are two sections to this graph. If there are two sections, that's an OR problem. So we want to go ahead and write it as an OR. If there's only one section, then you can write it as an AND. So what are we doing here? So what is this first section that's filled out? It's less than 2. So we want x less than 2. We don't want less than or equal to. It's an open circle. So this one's not right and D is not right. And now going over here, we're greater than or equal to 5. So greater than or equal to 5 is this one. So we're looking at B as an answer. We should be able to go ahead and do this. We should be able to go both directions. We should be able to graph it, and then we should be able to look at a graph and also come back. Two sections we're writing OR, one section we're writing it as an AND. Okay? That's what I have for you today.